Hello everyone, welcome to my channel Chemistry is Fun. In my previous videos, I have dealt with the topic of atomic structure in 4 parts. Today's topic is atomic structure part 5, and in this we will deal with some of the rules which can help to tell us how the electrons are to be filled in the orbitals. In my previous video, I have discussed about the quantum numbers. So this is in continuation to that. So let us see how the electrons are to be filled. There are some rules for that. The first one is Pauli's exclusion principle. It states that no two electrons in an atom can have the same set of all the 4 quantum numbers. That is, for any 2 electrons, all 4 quantum numbers cannot be the same. Even if the first 3 quantum numbers N, L, M are same, at least spin quantum number has to be different. Hence, an orbital cannot have more than 2 electrons because the spins must be in opposite directions. So, spin quantum number will be different. Here you see in case of 1s2, that is in 1s orbital, if there are 2 electrons, they have opposite spins as we can see in this, and one is designated as plus half, another is designated as minus half. So this we have to keep in mind when we do the electronic configuration. Next is Aufbau principle. It states that the electrons are filled in various orbitals in order of their increasing energies. That is, now see, if we see the first 3 orbitals like 1s, in the first shell there is only s orbital, that is 1s orbital. For the 1s orbital, value for n is 1, and since it is s, value for L will be 0. So n plus L is 1 plus 0, that is 1. For the 2s orbital, n value is 2 and it is s, so again 2s. For this n value is 2. What is L value? Whenever it is s, then it is L value will be 0. So n plus L is 2. So you see 2 greater than 1. So 2s filling has to be after 1s. That is, in order of increasing energy, 2s orbital will be having more energy than that of 1s. Then let's say 2p. In 2p, n value is 2. P means L value is 1. So n plus L will be 2 plus 1, that is 3. So 2p orbital even more energy than 2s. So its filling will be after 2s. So n plus L values gives us an idea about the increasing energies, and the electrons are filled in various orbitals in order of their increasing energies. An orbital of the lowest energy will be filled first, and then it will be according to the increasing energy order. Now there is a sequence of orbitals in order of their increasing energies, and that sequence is given like this. You see, 1s, 2s, 2p. These first 3 I explained on the basis of n value, L value and n plus L value. All others follow the same rule. So here you can see 1s, 2s, 2p. After that 3s and 3p. Then comes 4s. After 4s 3d. Then 4p, 5s. After 5s 4d. 5p, 6s. After 6s, f orbital will get filled, 4f. 4f, 5d, 6p. After 6p, 7s. Then 5f and 6d. So this is the order. The energy of the orbitals is governed by n plus L rule. I just told you. First we calculate n value, then L value, then we find out n plus L. So according to the increasing order, we will arrange. That is what I have shown here. Now, if there is a subshell with lower n plus L value, that means it is having lower energy. That will be filled first. Now, in case of 3p, in 3p, n value is 3, p means L value is 1. So, 3 plus 1 is 4. If we consider 3D, in 3D n value is 3 and D means L value will be 2 because 0 means S, 1 means P, 2 means D. So L value is 2. So 2 plus 3 is 5. So this is 4, this is 5. So 4 should be filled first. So 3P will be filled before 3D. In case n plus L values are same, then we have to see the n value which is having less n value, that should be filled first. Now see, in case of 3P and 4S, in case of 3P and 4S, 3P n value is 3, L value is 1, 3 plus 1 4. In case of 4S, n value is 4, L value is 0, so again 4. But in case of 3P, n value only n plus L is same for both here. But in case of 3P, n value is 3, n value is 3. It has a lower n value, so 3P will be filled before 3D. It will be filled before 4S in this case. Here we are considering 3P and 4S. For both, n plus L value is 4. Then we have to see the value of n, only n. So n value is less for 3P, so it gets filled before 4S. Next is Hund's rule. It states that no electron pairing takes place in the orbitals until each orbital is occupied by one electron with parallel spin. Now, first there should be single filling. In case of lithium, you see it is 1s2, 2s1. So in 1s, because 1s in first shell only s orbital is there, so both the electrons will be going to 1s. After that, the third electron is occupying 2s orbital. In case of nitrogen, 7 electrons are to be filled. First 2 electrons goes to 1s, so 1s2. Next 2 will go to 2s, so 2s2. You see there are upside and downside arrow, means they are having opposite spins, clockwise and anti-clockwise. In case of 2p, there are 3 orbitals, 2px, 2py and 2pz. Now see here, all the 3p orbitals are singly filled. It is not that in the first orbital we give 2 electrons and then next electron goes to the next p orbital. It's not possible. All the p orbitals are to be singly filled first. Then only pairing will start. Therefore, here in case of nitrogen, in p orbital we see each of these px, py and pz are singly filled. Pairing has not yet started. And also one more rule is there. It's another rule, new. Exactly half filled and fully filled orbitals make the atoms more stable. So 1s is occupied by 2 electrons, it will be very stable. 2s maximum capacity 2, if it is filled by 2 electrons, it will be very stable. Here in case of nitrogen, you see 2p orbitals, it is half filled. 2p3 maximum capacity is 6, but it is half filled. So half filled and fully filled orbitals will make the atoms more stable. Now, if there are atoms which consist of at least one orbital singly occupied, they will behave as paramagnetic, means weakly attracted to the magnetic field. They are paramagnetic, they are weakly attracted to the magnetic field. While those atoms in which all the orbitals are doubly occupied, they will be diamagnetic. They have no attraction for magnetic field. They have no attraction for magnetic field. Magnetic moment can be calculated if we know number of unpaired electrons. If n is the number of unpaired electrons, magnetic moment is given by square root of n into n plus 2 Bm. Bm is Bohr magneton. Bohr magneton. So magnetic moment is square root of n into n plus 2 Bm. Square root of n into n plus 2 Bm. Bm is Bohr magneton. Next we see how we can write the electronic configuration. So first, what is electronic configuration? It is the arrangement of electrons in the various shells, subshells and orbitals. Like we write 1s. So it is first shell 1. S is the orbital, s orbital. So the arrangement of electrons in various shells, subshells and orbitals in an atom is called electronic configuration. It is written as NLX. NL on top we write the text. N is order of the shell. L indicates subshell. X is the number of electrons which is present in the subshell. X is the number of electrons present in the subshell. So this is how we can write the electronic configuration. So students, I hope you all could understand whatever I explained today in this video. Please subscribe to the channel. And also you can go through my previous videos related to this topic, like atomic structure part 1, 2, 3, 4 is also there. You can easily go through them. It will help you in your preparation for the exam. Thanks for watching my video. Please share and subscribe my channel. Thanks for watching. Thank you all.